Okay, now we're going to talk about logs and converting them to their inverses. Here is your major inverse relationship. Notice that your x is always positive. Your base of your log is always positive and never equal to 1. I've always taught if I start with y equals log base a x, if and only if, I can change forms. I always called it snailing. I start with the base and I work my way around. It kind of makes a snail shape to me. So a to the y equals x. And if you don't see that snail, let me draw him for you. And there's a shell. Let's fill in what's missing on this chart. I've got my two major forms written up here. I'm going to snail this around to convert it. 2 to the 5th equals 32. Snail around. 3 to the 0 equals 1. It's not a good way of going the other way like a snail. Well, I guess you can still do it if you start with the base. That base of the exponent is the base of your log of 2 equals 1/2. Start with the base of the exponent, snail around. Log base 10 of 1/100th equals -2. Some properties of log. Anytime you're taking the log base a of 1, it's always going to be 0. Anytime you're taking the log base a of a, it's going to be 1. Log base a of a to the x, the a's will fall out. You're only left with x. And if log base ax equals log base ay, then x and y have to be the same. So let's look at these examples. Log base 5, 1. Anything, base anything of 1 is always going to equal 0. If the base and the number I'm looking at are the same, it's going to be 1. And this one's kind of going backwards off of this property, but if this base and this base are the same, I'm only left with 30. Let's look at the graphs. We've called them inverses, and if you remember, inverses are always flipped over the diagonal line, y equals x. And therefore, if I graph my exponential, 4 to the x, I know I can flip it over, put it in the same form, and I'm going to have log base 4x. So if I'm talking about the log function, the asymptote that was right here, it's now flipped to here. Now I have a vertical asymptote of x equals 0. So on an exponential, I had a horizontal asymptote of y equals 0. But on a log function, vertical asymptote x equals 0. Okay, here's an example graphing log base 10 of x to the 4th, or I'm sorry, x over 4. Notice all my errors right here. That's because my function is actually not quite getting to 0 because there is a vertical asymptote in the way. But then afterwards my numbers start increasing, not as fast as exponential. They actually increase very slowly, but they are increasing.